Okay, ignore that sound. Okay, so again, here's my equation I'm working from. Okay, here's my problem. Y equals 3 times 2, and I put the parentheses there. It's not like the multiplication dot. Okay, my A is 3, my B is 2. Okay, and I want to do for my X's. Remember, for my X's, I can make up my own X's and then calculate for the Y. Okay, so we're going to use -3, -2, -1, 0, 1, 2. Okay, because I just kind of happen to know where that's going to fall. Now, how do we get the Y values? Okay, well, where there's an X, we're going to replace here. Okay, so for the first one, it would be Y equals, paper doesn't want to act right. Okay, sorry about that. So I would do Y equals 3 times 2 raised to the -3, and I would type that in my calculator. And then Y equals 3 times 2 to the -2. Okay, and we're going to get those answers and put them up here in the table. We don't have to write them down here. Okay, writing it twice is not necessary. Y equals 3 times 2 to the -1. So I'm going to erase that equal sign. That's not necessary. Okay, and then Y equals 3 times 2 to the 0. And we keep going. Okay, so you know how to substitute, but you're going to substitute the X where it goes, which is the exponent. Okay, so we'll get my calculator so we can look at that, see what that looks like. Okay, so here we go. I'm going to do 3 times 2 raised to the negative, what did I say, 3? Okay, and we'll get that answer. 0.375. We're just going to go 2 decimal points, okay, and just get it close. Okay, so this is going to be 0.3, not 3 point, 3.8, and then we'll get 0.75, and then we should get 1.5, 3, 6, 12. Okay, so I wanted to use X values that I knew would produce Y values that will fit on my coordinate plane. Okay, so that's my goal there. Now, you can also, with your graphing calculator, do the table of values. Okay, so let me just remind you of how to do that, which is just a reminder because we've done this. If you're going to type it in your calculator, you go to Y equals 3 times 2, but this time you have to use the X so it gives you all of those values. Okay, and then we go to second graph, because remember the word table is blue, so I've got to push blue to get to it. And when I'm looking in the Y column, now on my actual coordinate plane, my highest Y value is 20. So when I look on my calculator for my table of values, I want my highest number to fit. This is 24, which is not going to fit. So 12 is as high as I want to go. So I know that 2 is going to be my lowest number. And then I can work backward from there. Okay? So that takes care of that. Now, let's talk about graphing these. Now that we have our points, we're going to graph those. Now, as a reminder, the exponential function is going to be very close to that x-axis, but don't touch it. Okay? Never intersects that x-axis. Okay? Matter of fact, let's make a little note to self down here. Okay? Just remind ourselves. Note to self. Okay? The graph never intersects the x-axis. Okay? It never intersects that x-axis. So we're going to, when we graph this, we're going to make sure we do not touch that x-axis, okay? So let's do that now. Because, and I want to say that ahead of time because when you're graphing the decimals, I'm not real particular about that. Get them kind of in the right place, but they don't have to be exact, okay? So, for instance, I'm going to go to -3 and then it's 0.38. Notice how the y value is counting, not y value, y axis is counting by 2s. So this is 1 here. Well, 0.38 is going to be very close to that x-axis. Just get it really close, don't touch it. -2.75 is still not 1. So we're going to bring it up just a little bit, okay? And then -1 and 1.5 be about right there. Just get it close, okay? That's all I need. Then 0, 3, that's halfway between 2 and 4. +1, 6. +2, 12. And then remember, 3 went to 24, which is off of my coordinate plane. Okay? So I'm not trying to graph that. Alright? But now, when I graph these, I have to turn it sideways so I can get close to that x-axis without touching it. So I'm going to get really close where I was going to bring it slightly outside that coordinate plane, get it really close, and then start connecting. The idea of your x values is to make sure you know where the curve is. Because exponential functions curve. They're going to come along that x-axis and then they're going to curve at some point. You got to make sure that when you choose your domain, you know you've got a good idea where that curve is happening. Okay? And then we'll come on up and I'm going to connect my other points. And then we'll head towards that 3. Okay? There we go. And that is what my exponential function looks like. Okay? So that's what it looks like. It should have an arrow on both ends because it extends forever in both directions. Okay? Not looking for perfection, looking for close. Okay? So get that close. Now let's talk about what our other characteristics are. Okay? So let's discuss those for a moment. Now, when I ask you what the x-intercept is, when we just said that the graph never intersects the x-axis, are we going to have an x-intercept, yes or no? Somebody talk to me. No. So my x-intercept is going to be none. Okay? That's none. But the y-intercept, and what I like for you to do is be able to look here and go, oh look, that is 0, 3. But I want you to also be able to find it in this table. So when I look at the table, how do I know it's a y-intercept? In order for it to be a y-intercept, what does the x value have to be? 0. So this is my y-intercept, 0, 3. Okay? Now let's talk about ending behavior that I know you really like. So here it is. End behavior as x approaches negative infinity, y approaches, now this one's interesting, because remember x is always left or right. So as this is pointing to the left, so my graph is going to the left, that's my negative infinity for my x's. But where is the y heading to? Is it heading to negative infinity? No. Because remember, it's never going to intersect this x-axis. So it's not negative infinity because it's never going to get down here to go to negative infinity. So interestingly enough, when we talk about exponential functions, y, okay, is approaching 0. Now remember, the word is approaching. It's never going to get there. Bless it. It's never going to get there, but it's approaching 0. Okay? So that's the end behavior for y. When you're talking about the end that is going real close to that x-axis. Okay? But now let's talk about when x is approaching positive infinity, y is approaching, now, x to the right is positive infinity. So now as I'm going to the right, what are my y values? They're going up. So now I have positive infinity. So with exponential functions, we have that little interesting piece going on. Okay? Any questions? Okay. The domain, since it has arrows on both ends, and my x-axis is horizontal, everywhere on this graph, on this function, there is an x value. I can go from here and go to the x. I can go from here and go to the x. Every point on this graph has an x value. Therefore, it's all real numbers. The range, where do the y values begin? Right? I'm going almost, it's going to get so close to that x-axis, it's never going to touch it. So what is the lowest point, the lowest value, y value, for this graph? Well, it's going to be 0. Okay? We're not going to get there. That's the lowest y value for this graph. So, if I'm at 0, the y values, are they greater than 0 or less than 0? Well, my graph is only all up here, so my range is only all the numbers greater than 0 because it never gets below here. Okay? Any questions as we look at this all together now? Are there any questions there? Okay. Do what? They're supposed to be speaking. If they have questions, they're supposed to be speaking. So, okay.